Okay, so today we're going to start part 2 of the solutions unit. So what you'll find in part 2 is we really focus in on the calculations part of solutions. So part 1 was kind of giving you the background and the theory on what a solution is, how things dissolve. We talked about solubility curves, some colligative properties, so you kind of got some of the background information. Now we're going to focus in on how do we do some calculations using this knowledge that we have. So today we're going to learn how to calculate concentration. And concentration is a measure of the amount of solute, so that's what's getting dissolved in a certain amount of solution. A concentrated solution has a large, a large amount of solute dissolved per liter of solution. So there's, like if we're thinking about a salt water solution, a concentrated solution has lots of salt dissolved, whereas a weaker solution would have a small amount. Something with a low concentration has a small amount of solute dissolved per liter of solution. To calculate the concentration of a solute in a solution, we use the unit moles per liter. So our very favorite unit, the mole, comes back to join us again. In other words, we work out the moles of solute per liter of solution. So moles per liter is sometimes called molarity or the molar concentration of a solution. So we're going to use this formula, and this formula is going to stick with you for the rest of this year and into grade 12. We use this formula a lot. So what this formula means, C equals N over V, is C stands for concentration, and we measure that in moles per liter. N is the number of moles, and V is the volume, and we measure that volume in liters. Okay, so very important that you make sure because we're measuring concentration in moles per liter, you need to have moles here and obviously liters here for volume. So this equation can be rearranged to solve for either not just concentration, but you can solve for number of moles, and you can also solve for volume. So let's just quickly show the different rearrangements of this equation. So let's say we wanted to solve for number of moles. Well, whenever I have a fraction, the first thing I want to do is get rid of it, and I want to multiply by the denominator. If I do that on both sides, what I get is N equals V times C, or C times V, however you want to write it. And I can also solve for volume. So let's go back to the original. Is N over V. So again, first step, get rid of the fraction. Okay, so that's going to give me N equals V times C. I want V by itself. So I'm going to divide by C on both sides, and I can rearrange that to be V is equal to N divided by C. Okay, so there's two other arrangements of that formula. So you can rearrange first and solve, or you can plug your numbers into the original formula, C equals N over V, and solve for the unknown, whichever you prefer. Okay, so this last little bit on the page is just something you're already familiar with doing. And because we measure concentration in moles per liter, you'll often have to make the conversion from milliliters to liters. So just simply use dimensional analysis like we always do to convert. So let's just take a look here. So this says convert the following into liters. So again, I know you've done the milliliter to liter conversion a number of times, so you will get to the point where you just do these in your head. But just to show you the full process, what we do is we'd write out 25 milliliters and we multiply by a fraction. We put milliliters on the bottom and liters on the top. And we know that in 1 liter, there's 1,000 milliliters. So we're dividing by 1,000. And when we divide by 1,000, we move our decimal place 3 spots to the left. 1, 2, 3. So that would equal 0.025 liters. And you can continue on and do the same thing with all of these guys. Okay, it's the same step every time. Divide by 1,000. Milliliters will cancel, and that will give you 0.3507 liters. Again, same procedure. So because you've done this a number of times, you'll get to the point you probably won't write this out. You'll probably just mentally shift that decimal place over. So you would get here 0.00775 liters, or if you wanted to write that in scientific notation, be 7.75 times 10 to the negative 3. And finally, this guy here, okay, if we move our decimal place over 3 spots, we get 12.456 liters. Okay, so that's a conversion you'll be doing a lot of. So let's give this a try. Use our formula and see how these work. I think you'll find them very straightforward. So it tells us here we have 0.86 moles of sodium hydroxide. It's dissolved in enough water to make a 250 milliliter solution. Calculate the concentration of the sodium hydroxide. So now here we only do have the 3 possible variables, and you'll only ever have 2 of those 3. So you may not find this step necessary, but if it helps you stay organized, you can list your variables here and identify them. So we've got 0.86 moles. Now we always want to pay attention to our volume. Our volume is listed in milliliters, so we want to make sure that's in liters before we go ahead and use our formula. So based on what we just did, we realized over time that as we divided by 1,000, we were shifting our decimal place to the left 3 spots. So what we actually have here is 0.25 liters. Alrighty, so here's our formula, C equals N over V. We know that N is, we don't know C, we know that N is 0.86 moles. And our volume, we have to use it in liters, 0.25 liters. So therefore, our concentration is 3.44 moles per liter. And it's as simple as that. So not a very difficult formula to use. And because it's only 3 different possible variables, it's pretty easy to identify which is which. Okay, what volume of a 0.25 mole per liter solution of glucose contains 0.10 moles of glucose? So this time we are looking for a volume, okay, and we have the concentration and the number of moles. So let's just list what we have here just to stay organized. Here's our concentration. in moles per liter. We've got 0.10 moles, and we're wondering what volume is that solution. So you can do, I'll do it two ways here, and you can choose. You can either rearrange the formula first. So if you remember on the last page, we did that already, and we showed that volume is equal to number of moles divided by concentration. So you can rearrange the formula first, and then it's just a matter of plugging in, well, this is how many moles we have, this is the concentration, therefore the volume would be 0.4 liters. Okay? The other approach would be to use the formula as it's originally given and plug in as is. So I would put my concentration here, my number of moles here, and my volume here. And then what I'd do to solve is I would multiply both sides by V. That would give me 0.25 V equals 0.10. And then to isolate V, I would divide by 0.25. And of course, I get the same answer. Okay, so either way is fine by me. I just want you to know that there's two approaches. Okay, so let's do one more. And then we'll change it up a little bit and add another layer to the problems. So a sample of laboratory ammonia has a molar concentration of 14.8 moles per liter. How many moles of ammonia is present in a 2.5 liter bottle? So again, if you like, you can identify the three variables. We know concentration is 14.8 moles per liter. And we know the volume is 2.5 liters, already in liters, so that's good. And it's wanting to know how many moles do we have. So again, choose which way you'd like to do it. I'm going to have the rearranged formula to start with. So we rearranged it on the first page of the notes, and we saw that the number of moles is equal to concentration times volume. So I'm going to take my 14.8 moles per liter, and I'm going to multiply by the 2.5 liters, and that will give me 37 moles for my answer. Okay, so let's now add in just one other little step. This will not be any sort of problem for you because you already know how to get between mass and moles, grams and moles. So if you have problems where some sort of mass is involved, you have to make sure before using your C equals N over V formula, convert from mass to moles before you begin. Or sometimes in the end, you get an answer in moles and you're asked for the equivalent amount of grams. So then you would do your conversion at that point. So let's just do some examples so that you can see what it is I'm talking about. A student needs 1.5 liters of a 0.12 mole per liter aluminum sulfate solution. What mass of aluminum sulfate must be used to make this solution? So this is a more realistic type of calculation because if you're preparing a solution in the lab, knowing the number of moles doesn't help you prepare the solution. You need to know the number of grams so that you can actually weigh that substance out on a scale and prepare your solution. So more often than not, you will need to at some point figure out this mass. Okay, so it says work out the number of moles of aluminum sulfate first. No problem, we can do that. So let's identify these variables. We've got 1.5 liters of solution, and we've got a concentration of 1.12 moles per liter. Okay, so we're gonna have to find out moles first. If you remember, this is the rearranged version. So I'm gonna take 0.12 moles per liter multiplied by 1.5 liters, and that will give me 0.18 moles. Okay, but the question is asking me, what is the mass? Remember, whenever you see the word mass, you want to think grams. Okay, so if we know how many moles we have, we can easily find out how many grams we have. So let's do this conversion that is very familiar. We need to know, first of all, what is aluminum sulfate? Well, aluminum sulfate's formula, aluminum is a +3 charge as an ion, sulfate is a -2. So it becomes Al2SO4 with a 3. Now, to get from moles to grams, you need the molar mass. So moles goes on the bottom, and the molar mass is how many grams are in 1 mole. Now, this number of grams comes from using your periodic table and calculating 2 times the mass of aluminum, 3 times the mass of sulfur, and in this particular case, it would be 12 times the mass of oxygen. So you can write that out if you like, or because you've done these calculations so many times in stoichiometry, I'm fine with you just calculating it and putting the number of grams in, whichever you prefer. Okay, so moles will cancel, and we're multiplying 0.18 by 342.17 to get 61.59 grams of aluminum sulfate. Okay, so just one additional step, and it's a step that you already know how to do. So let's try another one. 12.60 grams of sodium chloride are dissolved to make a 500 milliliter solution of sodium chloride. What is the concentration of the solution? So this time we're given a mass and we're asked to find the concentration. We know that before we can calculate the concentration, we need to know this amount in moles because our formula is C equals N over V. Concentration is measured in moles per liter, not grams per liter in this particular case. So let's take our 12.60 grams of sodium chloride and convert that into moles. So in 1 mole, how many grams are there? Well, I'd take the mass of sodium and add it to the mass of chlorine to get 58.44. Grams will cancel, and when I divide that, I get 0.216 moles. Okay, so now that I know that, I can go ahead and use my formula, C equals N over V. I now know moles, and I also know volume. But be careful because the volume is in milliliters. So don't forget you need to put that into liters. Now you can write that out if you wish, or you can mentally scooch these decimal places over 3 spots. So 500 milliliters is the same as 0.5 liters. So let's plug that in. And when we calculate that, we get 0.432 moles per liter. Whoops. There we go. Okay, a couple more and I think you'll have the hang of it. What volume of solution would be required to dissolve 36.75 grams of silver nitrate to make a 0.5 mole per liter solution of silver nitrate? So again, we're starting with grams. We're going to need to calculate volume. We can't do that unless we have concentration and number of moles. So step 1, convert that 36.75 grams of silver nitrate into moles. Grams on the bottom, moles on the top. This here is your molar mass, excuse me. So molar mass is silver's mass plus nitrogen's plus 3 times oxygen. Okay, so 169.88. And we divide to get 0.216 moles. All right, now we're looking for volume. So I'm just going to go ahead and use the rearranged version of the formula. Volume is number of moles divided by concentration. Number of moles I just calculated. And the concentration is given to me in the question, 0.5 moles per liter. So when I divide, I get 0.432 liters, which would be the same as 432 milliliters. Okay, what volume of a 0.055 mole per liter glucose solution found in a plant contains 2 grams of glucose? And the formula for glucose is given there to you. So again, we're looking for a volume. We're given a mass. We need to convert our mass to moles before we can calculate the volume. So very much like the question we just did. So take the 2 grams of glucose, which is C6H12O6, and do this conversion here. Molar mass is 6 times carbon plus 12 times hydrogen plus 6 times oxygen, and that would give you 180.18 grams. So our grams will cancel, and we're going to divide 2 by that number there to get 0.0111 moles. Okay, so now we go ahead and use our formula. Again, I've rearranged it first. So here we have our number of moles. Our concentration is in the question, 0.055. And that calculates out to 0.202 liters, which is the same as saying 202 milliliters. Okay, last one. What is the mass of potassium sulfate, K2SO4, in 50 milliliters of a 0.5 mole per liter solution? So we're looking for our answer is a mass. So our answer is going to be in grams. So before we can get to that point, we need to first calculate the number of moles. Okay, so maybe let's identify some variables here. We have 50 milliliters for a volume, which is equivalent to, move the decimal over, 0.05 liters, or use dimensional analysis. And our concentration is 0.50 moles per liter. So let's find N first. N is equal to C times V. So 0.05 moles per liter times a volume of 0.05 liters. Oops, I made a little error there. Our concentration is actually 0.5. There we go. Okay, and that would work out to 0.025 moles. We want our answer in grams, so 0.025 moles, and our substance is K2SO4. So moles go here, grams go here, and molar mass is 2 times potassium plus 1 times sulfur plus 4 times oxygen, which is 174.27 grams. And when we multiply, we get 4.36 grams. Okay, so at this point, you can stop the notes. There is a little section about different ways of measuring concentration, but we'll come back to that. And you can work on the first worksheet that goes along with this, which is, I think it is called Concentration, Dilution, and Mixing Worksheet number 1. So you're doing the part 1 section, which is about concentration.